Good evening to you all. And today, actually, my the lecture would be basically strictly exclusively for the PGTs of radiology. And in this class, I will be discussing about the screen film radiography and versus digital radiography. And firstly, the screen film radiography, I will be discussing about the introduction, and then about the contrast media, and then the filters, grids, cassette, and the intensifying screen, then X-ray film structure, then geometric factors in image quality, etc. And then I will be going to the digital X-ray technique. So basically, firstly, starting with the radiography, just as we all know that radiography is a medical investigation in diagnostic radiology in which X-rays are used to produce shadow picture of the patient, and this will enable us to visualize an internal structure of the patient, and it is the first imaging modality in medicine to obtain a two-dimensional image of the patient anatomy by using a X-ray film or digital detector. Now, if you see, if you just visualize a plain X-ray, you will get the same thing. Like X-ray is given, and there is the patient stands in front of the grid, and the just in front of the grid there is a film, and then the cassette are there, and there it is recorded, the image is recorded. So it is on that principle only, and now it is being modernized to a digital process, but the things the process remains the same. Now it is used in variety of diagnostics, starting from the bone imaging to chest imaging. And in radiography technique, actually the radiation from the X-ray tube is transmitted through the patient body and then reaches to the film or digital detector, and after processing the film, a radiograph is obtained, which is a negative image. Now always we should remember that radiograph is a negative image. Now the production of good radiological image requires a number of accessories, such as there are various accessories which we have to remember, that is the beam restrictor, collimator, filter, grid, and cassette, and an intensifying screen, and then X-ray film or digital detector in X-ray or X-ray unit. The principle of the above which I have told accessory, then I will be discussing with you in the following manner. Now, the radiological image, if we talk of the primary radiological image, that firstly we have to see that our human body is heterogeneous always. It is mainly made up of air, water, soft tissue, bone, differentiating density, and atomic number. So when X-ray passes through the body, now we have to remember this, when the X-ray passes through the body, it gets attenuated differentially and different tissues, and results in a variation of the transmitted radiation. Now this variation of is referred to as primary radiological image. Okay, and since the eye is insensitive to X-ray, the above image is converted into visible image either by using a X-ray film or fluorescent screen or digital detector. So this is actually the main principle on which the X-ray is done. And the screen that emerges from patient contains primary and scattered radiation. Only the primary beam contains the useful information of the patient, hence the scattered radiation must be removed before reaching the film in a diagnostic range. The X-ray interacts mostly on the photoelectric effect, which is proportional to the z to the power. It is z to the power. It is z to the power cube. It is z to the power cube. The companion, actually, the Crompton interaction is a minimum and mostly low with the Z material. Z is actually the atomic number is actually so, and so Z cube is the main photoelectric effect. So now overall photoelectric effect dominates over the Crompton scattering at the energy level. Hence, both the soft tissue and the fat will offer differential attenuation on two X-rays, and as a result, the transmitted radiation comes out of these organs and will also have variation. Thus, bone, soft tissue, and fat can be distinguished from one another. Always, it can be differentiated when an X-ray is being done. So now this should be very much borne in mind when we are dealing with the screen film radiography. So, and this can already be always be asked is an in a long answer question or in a short answer question. So now the coming to the second topic is the contrast media. Contrast media is also very important in the radiological point of view. Now contrast refers to the difference in density between the adjacent area of the X-ray. Now film, it arises due to differentiation is X-ray intensity transmitted through an adjacent parts of the patient's anatomy. Okay. Now it is usually called the subject contrast and affected by the incident photon energy and atomic number and density of the organ. Now photoelectric effect constitutes the high contrast subject contrast and low photon energies. Okay. Now it is also important here that when materials are of high Z, now when the materials are of very high Z, like calcium, iodine, barium are present in the human body, generally radiography has low contrast between the soft tissues. Okay. To overcome this risk, one should either use low kV technique on contrast media. So low kV contrast media, it can be used. The contrast agent absorbs X-ray either more or less than surrounding tissue, and they are necessary to visualize many organ in the screen with much details. Now contrast agents are used as improved subject to contrast, and they are basically radio opaque media, always it should be remembered, and they have high atomic number and maximize photoelectric absorption, and they are compounds of one or more elements, and their absorption edge should be just below the transmitted X-ray spectrum, and the type of contrast agents may be like it may be like air, then it can be iodine compounds, and then can be barium compounds. Now generally air has a negligible density compared to tissues and absorbs very little X-ray, hence air cavities can easily distinguish from other body tissue. However, its role is limited due to the arrival of CT and MRI, and it is only used in the double contrast barium enema examination. Now only just in the barium enema it is used now, due to the arrival of CT and MRI right now. And now for example iodine, where Z equal to 53 and KH equal to 33 keV, is also an excellent contrast agent. It can be injected intravenously to improve the subject contrast, and barium administered as a contrast agent due to the high Z, which is 56, and physical density, its KH is 37 keV, which matches with the photon energies used in the fluoroscopy. An organ filled with the barium or iodine absorb X-ray very strongly relative to surrounding and transmits very little radiation. So naturally the less radiation is there, thereby improving the subject contrast, and the characteristic radiation from the iodine and barium are energetic, leave the patient with and reaches the detector. Now in angiography, a vessel under an investigation injected with the contrast media, and initially an ionic iodine is used. It is replaced by a non-iodinic contrast media nowadays, and it has a low concentration also ions and reduce physiological problems and reactions. So actually this is the main definition which I have told about the contrast media, and you have to remember the contrast media, which contrast media fits for which, and which contrast media is least allergic, and which contrast media goes, and how the contrast media is given, what is the Z value, what is the KEV value, and what is the different types of contrast which are used, which generally we use. Now coming to the beam restriction and collimators. Now when we are coming to the beam restrictors and collimators, now X-ray beam restrictor, now we have to remember that what is the X-ray beam restrictor is a device that is attached to the X-ray tube. It is just attached to the X-ray tube hosting, and it regulates the size and shape of the X-ray beam. Now they can be classified into three categories. Mainly there are three categories where it can be categorized. Now namely aperture diaphragm, cones and cylinder, and collimator. So X-ray beam restrictors are cylinder or cone. It can be cylindrical or it can be conical. So these are the beam restrictor and a restrictor. And aperture diaphragms consist of short sheet of lead with hole in the center, and the size of the hole determines the size and shape of the X-ray beam. And we should remember that it is single aperture, can be altered in any size and shape. Now the disadvantage of aperture diaphragm is that it produced a large penumbra. This also we should remember. And the penumbra can be reduced by keeping the aperture diaphragm far away from the X-ray target. And aperture diaphragm are used in the dental radiography with rectangular collimation. In addition, used in trauma and chest radiography also. And the use of the conex and cylinders will reduce the penumbra considerably. Both have an extended metal structure that restrict the useful circular beam to the size. Now, if the X-ray source cone and film are not allied properly, they can then one can side the film and may be exposed, which is known as the cone cutting. Now, cone is an ideal beam restrictor, but the flare of cone should be greater than the flare of the X-ray beam. Now, it should be remembered here the cone of the ideal beam restrictor, but the flare of the cone should be greater always from the X-ray beam flare. Now, this system provides a limited number of the field size. Now, cone is used as a sinus radiography, which restrict the scattered radiation to the large extent. Now, the collimator is the best X-ray beam restrictor. Now, it declines. It actually defines the size and shape of the X-ray field that emerges from the X-ray tube, and the collimator assembly is attached to the tube hosting at the tube port. Now, it consists of two sets lead shutters which can be moved independently. Now, each shutter consists of 4 or more lead plates of 3 mm lead thickness, which one can absorb the X-rays completely to provide an X-ray field. Now, when shutters are closed, they meet the center at the X-ray field. Now, the collimator also has a light mirror attachment, and to illuminate the X-ray field, the light bulb is positioned literally, and the mirror is mounted to the path of the X-ray beam at the angle of 45 degrees. And this is also very important part, because it is giving the feature of the X-ray beam restriction and the beam restriction and the collimation. So it must be remembered. And the collimator also has light mirror arrangement to eliminate the X-ray field. The light bulb is positioned at as I told you, as an angle of 45 degree and mounted to the path of X-ray beam, and the target end of the light bulb should be kept at an equal distance from the center of the mirror. And the collimator provides a variety of rectangular X-ray field, and the light beam shows the center of the X-ray field, and the light film radiation field should meet exactly with each other, referred to as the field congruence. Now, there can be a question, it can be asked that what is field congruence. So, when the question comes as a field congruence, we have to define totally starting from the reactors and collimators, and you have to give all the definition individually here. So, light field congruence is this only. And now, the variation must be within 4% of the SID and the alignment of the beam of the X-ray. Now, a beam should be checked periodically. A well collimated beam over lesser area of the pattern gives a very less dose, and it also generates less scatter radiation, which improves with the quality image. And collimators are anatomically limit the X-ray field due to the useful area of the detector that is also available, referred to as the positive beam limitation. Now, the positive beam, that is PBL, is also available collimators. A sensor is a cassette holder. Now, a sensor is also there, which is a cassette holder. Adjust the collimator operating equal to the cassette dimension. Thus, PBL collimators limits the individual volume and reduce the patient dose. So, this is the main ideology, and this is the main methodology, that we have to reduce the dose giving to the patient, so that the exact the X-ray is also taken out and the minimum dose is given to the patient. Now, I will actually conclude because the screen film radiography is actually a long topic. Now, I have just today only I have just discussed about the beam restriction and collimators, and about contrast media, and primarily radiological image and definition of the radiography. Now, in the next part, within a day or two, I will be giving the part 2, where I will be discussing the filters and the type of grids, etc., which is very important, because grid as alone comes as a question with diagram, that what is the grid and what is the grid ratio and how it is produced and what are the steps, etc. And you should know you are expected as a PGT to know everything about grid, everything about radiography, and in total in a very, very long question the question are always asked. So in the next part 2 of this same chapter, I will be discussing about grids and filters, and then moving ahead towards the cassette, and then intensifying screen, and all the details of the X-ray film structures, and then the adhesive layer, then how to print printer, and speed, and the density measuring with the graph, with the sigmoidal graph, etc. That I will be discussing with X-ray film processing, etc. Now that I will be doing within a day or two in the part 2 of this same chapter. And firstly, this I am now discussing, and if you have any query, or if you have any doubt on this, particularly this part, you can always ask me in either in my chat box, or either in my WhatsApp number. So till then, you just go through this particular chapter and revise. Thanks a lot.